Bismillahirrahmanirrahim. Now we are starting the second part of lecture number 6 and continuing with the examples of multiple integrals in two variables, that is x and y. So starting with another example. This time we need to evaluate double integral over any area a x square dx and dy. This is the integral what we need to integrate, where a is the region in the first quadrant, where a is the region in the first quadrant, where A is the region in the first quadrant bounded by the hyperbola, and let's say the equation of the hyperbola is xy is equal to 16, and then we have and the lines y is equal to x. One line is y is equal to x, other is y equal to 0, and x is equal to 8. So we have four different lines and curves to make that complete area. So as we did in previous examples, first of all we will draw the figure to work out the area required to be calculated. So this is x-axis and this is y-axis. Now we need to draw these four lines or curves. So keep it in mind that it is not mandatory that we always follow the same order of drawing these lines or curves. We need to draw all four or all three. Whatever order you feel is suitable for you, you can follow that one. For example, I know that y equal to 0 is x-axis. So I draw this here, that this is y equal to 0 line. Then for example, x equal to 8, so let's say 1, 2, 3, 4, 5, 6, 7, 8. So this is, let's say, line x equal to 8 line. This is x equal to 8. Then for example, need x equal to y line. So let's say this is going to be the x equal to y line. This is x equal to y line when x and y both have identical values. And then we have a hyperbola, that is xy equal to 16. So in the first quadrant, it will be like this one. It will be like this one. So this will be the xy equal to 16. So now it is very easy to find the point of intersections of all these. This is at origin, so it means this is 0, 0. Here we know this is x equal to 8, so 8, 0. So what will be this point? This is x equal to 8. So what will be this point? Because this point is intersection of this and this, and here x equal to 8. So if I substitute x equal to 8, I will find that y will be equal to 2. So this point will be 8, 2. And then at this point I know all the values of x and y are equal, and here x equal to y, and this is xy equal to 16. So if I substitute x equal to y, then this is y square equal to 16, so y equal to 4. So if y equal to 4, x will also be equal to 4. So this will give me this point. So very simple and straightforward way. You can solve on paper as well the point of intersection. It is not mandatory that you will follow the idea of orally solving this. if you are not comfortable with orally solving these equations, then you can do it on your paper or on rough pages, but we need to find the point of intersection where these lines or curves are intersecting each other. Now, the other important point is this, that in order to find this area, it is important for us to make it in two, because this is not a well-known figure to calculate the area. So it is better to split it in two ways, so then it will become much more easier for us. So drawing a perpendicular from here, I am drawing in a dotted line, so it will give you an idea that this is drawn after drawing the figure. So now, if I like to know that what will be this point will be 4, 0, because x equal to 4 and y here will be 0. So now I have two regions to find the area. One region is O, let's say this point is A and this point is B. So one region is OAB. And if this point is C and this point is D, so one region is ABCD. So there are two different regions, and if I need, then I can find this separately and this separately and then add, so I will able to find the area of the whole this figure OBCD. So it means, first what we write, that the given integral will be distributed in this form. What is the form? That integral over ax square dx will be integral over OAB x square dx dy plus integral over ABCD x square dx dy. I will find separately this one and this one. This is the triangle OAB and then the quadrilateral, that is ABCD. So now it is important to understand that which thing which holds which values. So it is not mandatory to highlight in words that this thing holds these values, but it is only mandatory to write it correctly. So now we are following the same pattern, that we are solving with respect to y first and then with respect to x here. With respect to y first and then with respect to x. So the limits of x will be 0 to 4 and the limits of y will be 0 to x. The limits of y will be 0 to x, because y is here 0 and y is here x, and then x is 0 and 4. So limits of x will be 0 to 4 and limits of y will be 0 to x for the triangle OAB. Then similarly for the triangle, for the quadrilateral, we are again following the same pattern, that we are trying to integrate with respect to y first and then with respect to x, what we did in this here. So the limits of x will be 4 to 8, and then we have x square dy and dx, and here we have the limits from 0 to 16 upon x. How we conclude that? Because for this portion the x is varying from 4 to 8. So that is why I write 4 to 8, and for this portion x is varying from 0 to 4, so I write it 0 to 4. So I covered the whole area. And then for y, we are starting from 0 to what? if from here y is equal to 16 upon x, and from here y is equal to x, so I write 0 to x and 0 to 16 upon x. So I hope this will be clear to you, and now it is time to just integrate and substitute the values. So it become very straightforward and simple that how we conclude that. So here it is 0 to 4, and then on integrating we will get x square y and 0 to x dx plus 4 to 8, and then we have x square y and limits are 0 to 16 upon x and dx. So what we get? We get from here, this is 0 to 4, and then x square. When we substituted the upper value x minus 0x, so it is x cube and dx, and from here this is 4 to 8, and then it will be like 16 upon x, so x cancels with x, so 16x dx. So what I find that this is 16x 4 to x and x cube. So now integration is now much more easier and straightforward. So it is x power 4 by 4, 0 to 4, and plus 16x square by 2 means 8x square, and this is 4 to 8. So finally I have 1 by 4 and 4 power 4, 4 4s are 16, 16 4s are what I will get. Okay, I will write 4 power 4 minus 0 power 4 plus 8. This is 8 square minus 4 square. So it means this is equal to 4 cancel with 4. So 4 4s are 16, 16 4s are 64. So this is 64 plus 8 square is 64 minus 4 square is 16. So 48. I will get 48, and 48 multiplied by 8, this will be 48 multiplied by 8, I think this is 364, 48, 8 is a 64, 364, I hope this will be 364, 8 is a 64, 384, 8 for the 32 plus 6, 384, so it will be 4 4 8. This is 4, 4 4 8, 4, and then 3 and 1 4, 448. I hope this will be correct if I added correctly. So there were two things important in this example. Number one is that I solve it in two split portions. So if needed, we can do it for our satisfaction, that we can solve this portion separately and this portion separately. It is allowed to us, and sometimes it is required in the question that try to figure out each and every part of this area. So now moving on to another example of the same kind, and then inshallah we will move to few examples for you as well. So now I am writing another example to establish the same idea. So now I am evaluating, this is the double integral, and then I am taking x square plus y square dx dy. Evaluate this integral throughout the area, enclosed by So what now we are enclosed by the curves. Again I am taking 4 different curves. Number 1 is y equal to 4x, y equal to 4x, then x plus y equal to 3, then we have y equal to 0 and y equal to 2. So again starting the solution by drawing all these 4 curves. So let's say again this is y equal to 0, so this is y equal to 0, this is x axis and this is y axis. So this is y equal to 0. Let's say this is 1 and this is 2. So this is y equal to 2. So let's say this is 1 and this is 2. I am taking as 1 and 2. So this is the line that is y equal to 2. This is y equal to 2 line. Then we have a line y equal to 4x. So let's say this is the line that is y equal to 4x. In order to highlight the area, I remove this extra line, and then x plus y equal to 3. So this is the line x plus y equal to 3. So I draw all these 4 lines. So x plus y equal to 3, y equal to 2, all these 4 lines, I draw these lines. So now looking at that, what will be the 4 points? So it is origin. So this will be at 3, 0. This will be 1, 2 and this will be meeting at 3, 0. How I find that? This line is y equal to 0 intersecting with x plus y equal to 3. So if I substitute y equal to 0 here, this will give me x equal to 3. So this is 3, 0. So again now this and this point, what will be y is equal to 2. If I substitute y equal to 2 here, this will give me the value of x as 1. So the point is 1 to 2, because here x equal to 1 and y equal to 2, and again this is y equal to 2 and y square is equal to 4x. So I can easily calculate this point. If I substitute y equal to 2 here, then x will be equal to 1 by 2. So this point is 1 by 2 and 2. So it is most important to highlight all these points very carefully, because once we made any error in calculating these points, then eventually the area that calculated will be based on error, because we made an error in calculating these point of intersections. So I am again repeating for you that it is not necessary to calculate orally as I am calculating, but you can solve these equations separately on graph sheet to find the point of intersection, because this point of intersection is y equal to 0 and x plus y equal to 3, both are linear. So solve these, then this is x plus y equal to 3 and y equal to 2, and this is y equal to 2 and y equal to 4. So all these linear equations, so you can easily solve simultaneously and get the point of intersections. Now it is easy to find out that I can easily divide this in 3 pieces, 1, 2 and 3, a triangle, a rectangle and a triangle. So it will become more easier for us to easily calculate the area. So if I say this is O, A, B, C, D, E. So then we can easily, so now the given integral can easily be distributed in 3 parts And what are they? That this is x square plus y square dx dy is equal to, what is this? The integral over the triangle OAB, x square plus y square dx dy plus then ABCD, the rectangle, x square plus y square dx dy, and then again the triangle CDE, so x square plus y square dx dy. So we can easily distribute this actual integral in three parts to calculate all these areas separately and easily. So now going on to one by one. So because I do not have place, so I am highlighting this. This is I1, this is I2, and this is I3. So we can easily solve all these integrals one by one. So for I1, and let's say this is I, so I equal to I1 plus I2 plus I3. So now I1 is equal to, so now I am highlighting the limits and following the same order. And what was the order? That integrating with respect to y first and then with respect to x. So what are the limits of x? X are 0 to half, 0 and 1 by 2, because here x is 1 by 2, and what are the limits of y were 0 to 4x. So it means when I will calculate, this is 0 to 1 by 2, and then I have with respect to y, so x square y plus y cube by 3, and then 0 to 4x. X square y and y cube by 3, and we need to integrate, substitute the values from 0 to 4x. So it will be 0 to half, and what we get, if we substitute in place of y 4x, it means 4x cube, and then when I substitute the second one, 4x, 4 4s are 16, 16 4s are 64, then it will be obviously 64, then it will be 64 y cube, no sorry, 4 4 the 4, 4 4 the 16, 16 4 the 64, x cube upon 3. And this is, sorry, I missed to write dx here, dx equal to dx. So if, because this is x cube, this is x cube, so if I add both these, I will get 0 to half, and this will be 3 4s are 12, 12 plus 64 is 76, 76 upon 3 x cube dx, it means 76 upon 3, and we have x4 upon 4, 0 to half. x4 upon 4, 0 to half. So it means what I will get? I will get 76 upon 3 into 1 by 4 and into 1 by 2 to the 4, 4 to the 8, 8 to the 16. So this will give me overall what is the value? Value will be 19 over 48. Four ones are 4, 4 ones are 4, 4 nines are 36, so it is 19, and 16 threes are 48. So I1 will be equal to 19 upon 48. So now similarly we will calculate I2 and I3 as well. So now I am removing this question from here to calculate I2 and I3, but not removing the figure, so I know the limits of the I2 and I3. So now calculating I2 will be equal to integral, we have x square plus y square dy and dx. So these will be half to 1. The values of x is from half to 1. The values of x and the values of y will be from 0 to 2. Values of y will be from 0 to 2. So it means this will be equal to half to 1, and then we have x square y plus y cube upon 3, and limits are 0 to 2 dx. So it means this is equal to integral half to 1, and then if I substitute 2 here, that is above limit, so this is 2x square, no sorry 2, yes 2x square, and then substituting 2 here, 2 2s are 4, 4 2s are 8, plus 8 upon 3, and lower limit is 0, so this is dx. So 2x square plus 8 upon 3, and now limits are half to 1. So now again integrating with respect to x, so it is 2 upon 3x cube plus 8 upon 3x. So now limits are half to 1. So if I substitute, this is 2 upon 3. So 1 cube is 1 minus 1 by 8 and plus 8 upon 3, 1 minus 1 by 2. So it means finally what I have 2 upon 3 is 7 upon 8 plus 8 upon 3 is 1 by 2. So it means 7 by 12 plus 4 by 3. So this will be equal to 23 by 12. Hopefully this is 23 by 12. Yes, this is 23 by 12. So now the final integral, that is I3. So for I3 we have integral x square plus y square dx dy, dy and then dx. And now what will be the limits of I3? This is 1 to 3. The limits of x will be from 1 to 3, and the limits of y will be from 0 to 3 minus x. 0 to 3 minus x. So if I calculate 1 to 3, this is x square y plus y cube upon 3. So we have 0 to 3 minus x. This is dx. And now I am cleaning this I1. So what we will get now, so this is equal to 1 to 3, and this is x square, substituting 3 minus x, and plus 1 upon 3, 3 minus x whole cube, and this is dx. So this is we integrated very carefully, and now it's time to, we substituted the values as well. So we can easily integrate this one. If I write 1 to 3, and initially this is, the first term will be multiplied, so it is 3x square minus x cube, and then plus 1 by 3, 3 minus x cube, and this is dx. So now we can easily integrate all these terms. So this will be equal to x cube minus x power 4 by 4 plus, minus 1 by 3, 3 minus x power 4 by 4. Because the derivative of 3 minus x is minus 1. So this minus plus will become minus. So 3 minus x power 4 by 4, and we need to substitute the value from 1 to 3. So this will be equal to, if I substitute in this term, so this will be 3 3 is 9, 9 3 is 27 minus 1 by 4, 3 3 is 9, 9 3 is 27, 27 3 is 81 minus 1 upon 12, and then 3 minus 3 is 0, 3 minus 3 is 0, and then minus 3 minus 1 is 2, 2 power 4, 2 to the 4, 4 to the 8, 8 to the 16, so this is 0 minus 16. So it means we finally have, this is 27 minus 1, 26, then minus 81 minus 1, 80, 80 divided by 4, 80 divided by 4 is 20, 26 minus 20, and then minus plus 4 4s are 16 and 3. So 26 minus 20 is 6, minus 4 upon 3 is 3 6 are 18, 18 minus 4 is 14 upon 3. So final answer will be maybe 14 upon 3. No. 27 minus 1 is 26, 3 3 is 9, 9 3 is 27, minus 1 by 4, 3 3 is 9, 27, 81 minus 1 is 80, 80 upon 4 is 20, and then minus plus, oh sorry, this was plus, and this was plus, so 3 6 are 18, and 18 plus 4 is 22 upon 3. Hence I will be equal to I1 plus I2 plus I3. This was 19 upon 48. Then we have 23 upon 12, and then we have 22 upon 3. So if you add all these, you will get 463 upon 48. So this is the way to find out all these values, and inshallah in the next segment I will write few examples for you for your solution. So it's goodbye from now.